Let's continue with our cloud journey. In the last episode, we've got our dev environment ready and we've created our first cloud service from scratch. Today, our main goal is to understand some of the basic concepts of cloud computing, and we'll deploy the service to Windows Azure and see how it works on the cloud. So let's get started. Now I'm back in the Hello Cloud project we've created in the last episode. Before we try to deploy it on the Windows Azure, let's try to launch it again by pressing F5. You can see the computer emulator is starting up. And once your computer emulator is started, you can find a little icon on your taskbar, and you can right-click on it and bring up a Compute Emulator UI. You can see here in my simulated cloud, I have one deployment of my cloud service, and for my Hello Cloud web role or website, I have one running instance. There are several concepts at play here, but let's focus on one concept, the role instance. And let me bring up my notepad as a whiteboard, and I'll try to explain the concept of a role instance. But before I can do that, let's review the concept of a cloud service. As we mentioned in the last episode, we can view a cloud service as a box where you can put different roles in it. For instance, in our case, we put one web role in it, but you can put other roles, like a worker role or virtual machine role. But we'll talk about those role types later. Let's say now in this cloud service, I'm putting several roles. Let's say role 1, role 2, role 3, and more. So this is what we already know. Cloud service is a box and we can put roles in it. But what we didn't mention is, when you design a cloud service, for each of the roles, you can actually specify how many instances you want for each of the roles. For example, let's say we want 2 instances for role 1, and we want 3 instances for role 2, and for role 3 we want 1 instance. Then what is an instance? An instance is a virtual machine runs on Windows Azure. And on the virtual machine, of course, we have the guest OS, for instance, Windows Server 2008 or 2012. And we have service bits. For instance, your website files and assemblies and other binaries that you may need for your role. And there is something else, but for now we'll just say there's something else, X. We don't care that yet. And if we map that to our cloud service, to our Hello World or Hello Cloud cloud service, our cloud service is a box with one web role in it. And for this web role for now, we have 1 instance. So let me finish the equation here. So that's what we have now. But let's come back to this example, the cloud service with multiple roles and multiple instances. What happens when you deploy this cloud service to Windows Azure? So the Windows Azure will open up this box and examine what's the definition within the box. And it sees, okay, actually it needs to create 3 roles, and for each role it needs to create this number of instances. For role 1 it needs 2 virtual machines. For role 2 it needs 3 virtual machines. For role 3 it needs 1 virtual machine. So when we deploy this cloud service to Windows Azure will actually start 6 virtual machines for our cloud service deployment. And for each instance of the same role, the virtual machines will have the same service bits. And let's see how we can configure that in Visual Studio. Now I'm back in Visual Studio. Let me stop the service. And I will open up my cloud project and double click on my web role. And here you can see at the configuration tab, I have an instance setting. Now I'm saying I only want one instance of my web role, but I can easily change it, let's say 2. Then I save the change, and we'll just press F5 to relaunch the application again. And if I bring up the Compute Emulator UI again, you can see now I actually have 2 instances running. So this is all good. But why? Why we want 2 instances of our website? Let's go back to our notepad. From the definition of row instance, you can see the row instance is nothing magical. It's a virtual machine running in the data center with Windows operation system on it, and in our case with IIS and our website running on it. So naturally it has its capacities. Let's say the virtual machine has the capacity of handling X requests per second. And what if we want to serve more customers? The first obvious way is, of course, to make the X bigger. This is what's called scale up. To scale up, basically you are increasing the capacity of your row instance. Let's say by providing more CPU power and more memory, etc. So this is a scale up. You're improving the capacity of one server. But scaling up has its limitations. On the hosted environment, you only have a number of choices of virtual machines. You cannot just pick whatever virtual machine configurations you like. You run out of options pretty quickly. And even if you are doing scaling up on the on-premise system, you'll probably run out of physical spaces to throw in more hardware to handle more requests. So scaling up has its obvious limitations. And furthermore, when you do scaling up, you are changing the machine configuration, either the virtual machine or physical machine configuration. That probably means you will need to take the machine down, so that will cause interruption in your service. So the scaling up is usually not a good choice on the cloud environment. The other option we have is to scale out. In this case, instead of trying to make the X bigger, we'll just throw in new X's. We'll just keep adding new virtual machines. Each has the capacity of X requests per second. In this case, we can infinitely scale our system to add as many X's as we want. So this is called scale out. Scale out has some advantages over scale up. First, you can infinitely scale. Right? You can throw in as many X's as you want. There's no limitation. The second, you're scaling out by adding new servers. The existing servers are not impacted, which means you can scale out your application to increase the capacity without bringing down your service. So these two are very significant benefits over scaling up. However, scaling out has a problem. When we do the scale up, when we try to increase the X, all our client or our customers are still connected to the same box, to the same IP address. So they will have no problem to connect to our service. However, when we add more boxes, when we add more virtual machines into our system, each of the box will have different IP addresses. How do our clients connect to our system? Do they know which IP address to connect to? And do they know how to distribute themselves evenly so we don't overload some of the servers but leaving the other servers idle? The solution to this problem is to use a load balancer. Without going into too much details, let's just say a load balancer is something that can provide a public address our clients can connect to, and it can forward requests to our instances. Let's say this load balancer is connected to 3 instances. Let's say instance 2. Let me put instance 1 here and instance 3 here. And when requests come in, the load balancer will evenly distribute the workload across all running instances. For example, a request might be routed to instance 1, then the next request might be routed to instance 2, and the next request might be routed to instance 3, and so on and so forth. So that's the load balancer at work. When I publish my service, I will get a public address in the format of my service name .cloudapp.net. Let's say for website, we are using default port 80. So that's the public address our clients will connect to, or our customers will use to access our service. And internally, the load balancer will forward the requests to our virtual machines. Let's say for this one, I have a, let's call it private IP for now, or we can call it virtual IP, which will come back later. Let's say this is 120 and 0.1. And maybe I'm using port 80, maybe I'm using some other port, let's say 8001. And the other virtual machine might be 0.2, 8001, and the third one might be 100.0.3, 8001. So here you see on the left, I have my public address. And on the right, I have my virtual IPs for each virtual machine. And I can use a different port than the port that is exposed to our clients. And now let's try to publish our cloud service to Windows Azure. And this is how you do it. In Solution Explorer, right-click on the cloud service and select Publish. Before we can publish to Windows Azure from Visual Studio, we need to import our subscription credentials. Sometimes it's referred as a publish profile. Click this link to download your credentials. And this will take you to the Windows Azure Management Portal, where you'll sign on with your Microsoft ID. Then you will be able to download your published profile here. I just save it. After I've downloaded my profile, I can go back to Visual Studio and I can import it into my Visual Studio environment. Here I have multiple subscriptions. If you have only one subscription, that's the only option you will see here. But here I have multiple ones, so I can choose which subscription I want to use. I choose the subscription and I say next. And here I'm going to create a new cloud service. Cloud service names have to be globally unique. So here I have to pick something that is less likely to conflict with others. Let's say hi she says hello. Then I need to pick a data center where I want to deploy my cloud service. Remember that my cloud service instances will be just virtual machines in the data center. So here I'm going to pick from one of the 8 data centers we have so far. Let's say the West US, which is the closest to me. And I'll just say OK. And by now I can actually just simply click on the Publish button and it will be published. But before we do that, we do one of the advanced options. We'll enable remote desktop to all my instances. To do this, I will check this checkbox. And the wizard will ask me to create a Windows account that I can use for the remote desktop. So here I'm saying I'll create an admin user. I just say OK. Now I can click on Publish. And the application is being built, packaged, and uploaded to Windows Azure. then Windows Azure will read our package and create enough virtual machines. In this case, it will create 2 virtual machines, deploy our website to both virtual machines, and put them behind the load balancer, and expose the public address, which is hello.cloudapp.net, that we can use a browser to connect with. And in the activity log window, you can see what is actually going on. You can expand this message to see what are the operations is being performed by Windows Azure. Now that took several minutes. And let's go to our cloud service on Windows Azure and see how it works on the cloud. We'll click on the link, which is hello.cloudapp.net, as we just described. And let's see how it works. Now you can see my cloud service running on Windows Azure. And when I refresh my page, the page is actually served from one of the 2 running instances. Of course, here we cannot tell which instance is actually serving the request, but in the next episode, we'll actually modify our page so we can surface some of the row instance details onto the page. And there's another interesting point here. Because I have 2 instances of my website, if one of the instances goes down, my website is still available because I still have the other instance serving up the requests. Of course, in this case, my capacity is only X requests per second, but my service remains available. And that is actually one of the benefits of the cloud platform, which is to improve the availability of your service. And what happened behind the scenes is the Windows Azure will take the broken virtual machine down and start a new virtual machine, deploy our bits, and put that virtual machine back to the load balancer so we can come back to the X plus X capacity. But that all happens behind the scenes. Your user don't need to know. So there you go. We have our first cloud service deployed on Windows Azure, and we have 2 instances running to improve both throughput and availability. So in summary, today we went through some of the basic concepts of Windows Azure Cloud Service. We talked about how we can view Cloud Service as a box where you can put different rows in, and for each row you can specify how many instances you want. And the row instance is nothing more than a virtual machine plus guest US plus your service bits and plus something that we don't care yet. And we talked about scale up, which is to increase the capacity of a current server, or scale out, which is to add more servers so you can infinitely scale out your service. And we talked about load balancer, which provides a public address for our service, and it distributes the workload across all running instances. And when we have multiple instances, if one instance or some of the instances go down, our service remains available because we still have other instances to serve up the request. And eventually, we published our cloud service to Windows Azure. We downloaded our publish profile, and we completed the publish wizard. Thank you for watching, and see you next time.